Assalamu alaikum. Hello friends. In this video, we will learn about Planck's quantum theory, the term quantum, main idea of the theory, difference between quantum and photons, and the units. Planck's quantum theory is enunciated by Max Planck, who was a German physicist. The theory asserts that the energy of quantum is directly proportional to the frequency of radiations. In simple words, the theory can be written as this. E represents the energy and F represents the frequency. This is the mathematical representation of Planck's quantum theory. Now before we further, let's understand the term quantum. Quantum is a small discrete energy packets, or you can say the carrier of energy. Quantum is solely composed of energies. Quanta is the plural form of quantum. The main idea of the theory is that the emission and absorption of energy in an atom or matter takes place in a form of quantum. This is the major outcome of Planck's quantum theory. To understand the theory in a better way, let's take some illustrations. I choose hydrogen atom for the sake of simplicity. This dot, here are some cases, case 1, case 2 and case 3. This dot represents the electron of hydrogen atom, the excited electron. In case 1, the excited electron loses some amount of energy and falls back to its ground state, or you can say original orbit, by the emission of some radiation in a form of quantum. In case 2, the excited electron jumps from second orbit to the first orbit by the emission of energy or radiation in form of quantum. I have calculated energy and frequencies in both cases. As you can observe that energy and frequency in case 2 is slightly higher than the energy and frequency in case 1. In case 3, the electron jumps from fourth orbit to the first orbit by the emission of radiation. Remember that the emission of these radiations are emitted in a form of quantum. The energy of this radiation is 2.04 exponent negative 18 joules and the frequency is 3.08 exponent 15 hertz, which is higher than the previous ones. Now we have studied transition of electrons from 3 different orbits corresponding different energies and different frequencies and representing different radiations. And you can easily notice that in each case the increment in energy causes the increment in frequency, which shows the direct relationship between them. Now the question arises that why energy corresponds to the frequency, or in other words, why they are directly proportional to each other. To answer this question in a broad perspective, we can say frequency is the speed of wave or particle. Let's name these radiations as A, B and C. Let's write it down separately. This is radiation A of case 1. This is radiation B of case 2. And this is radiation C of case 3. Remember that they are not continuous waves. They are discontinuous particles which travels in a wave-like pattern. Let's say that the radiation A has X amount of energy. So it corresponds to the X frequency. The radiation B has more energy than radiation A, so its frequency is more than the frequency of A, and it can accelerate faster. Similarly, The radiation C has even more energy than radiations A and B, and it accelerates even more faster. In short, higher energy corresponds to higher acceleration, or you can say frequency, and vice versa. The more energy the radiation have, the more it can go farther, or the more it can accelerate, and the more higher frequency it possesses. Now, one important question is still remain unanswered. That is, are photons and quantums same? No. Photons and quantums are not same. There's a little bit confusion in this concept. Well, all photons are quantums, but all quantums are not photons. Or quantum of electromagnetic radiation are photons. They are always photons. However, in case of phonons, W and Z particles, and gluons, and some other examples as well, the quantum are not photons. They are neither electromagnetic particles, and they does not travel in a wave-like pattern in these cases. The last thing remains the units. This is called Planck's constant. It's the fixed value. It has fixed value, which is 6.62 exponent negative 34 joules into seconds. This is the SI unit. Let's derive the units of Planck's constant over here. From the mathematical representation, we can use simple maths. This F goes here in the denominator. Energy is measured in joules, and frequency is the reciprocal of time. Reciprocal of time period. Time is measured in seconds, so 1 over seconds. Doing simple and basic mathematics, we can derive the units as joules into seconds. This is the most common units of Planck's constant theory. This is the basic understanding of the theory. If you have any confusions, questions, or queries regarding this video, you can write me at online_learning@outlook.com, or you can like and visit my page Online Learning Pakistan. Thank you so much for watching.